Hi everyone. In this video, I am going to discuss the question number 8, 9 and 10, which is exercise 6.2 of the NCRT, the chapter name as the triangle of class 10th. Already I have discussed the previous exercise 6.1, and in the 6.2 I have also discussed the question 1 to 8 in the multiple videos. So now I am going to discuss this question. Before watching this video, I would like to tell you just you have to watch those into the sequence manner so that you could understand, because I have already teach you the concept through which how you will able to solve this question. So now I am going to solve this question. So as I teach you the two concept, one is the what is the difference between congruency and the similarity, and the some rules of the congruency similarity, and also talking about the BPT concept I had already teach you. So now in this question number 8 we have to prove that using the theorem number 6.2. So what is the theorem number 6.2? It is the BPT theorem, basic proportionality theorem. So using the BPT theorem prove that a line joining the midpoint of any two sides of a triangle is parallel to the third side. So what we have to prove? So as we have let's suppose a triangle named as the A, B and C. As it is saying that prove that line joining, a line which is joining the midpoint of any two sides of the triangle. Let's suppose we have the two sides AB and AC. The midpoint of AB be let's suppose the E, and the midpoint of AC let's suppose the F. So line joining the midpoint of AB and the AC, which is the EF, will be parallel to BC. So we have given what we have given. Given that in the question we have that E is the midpoint of AB, and F is midpoint of AC. So we have given to prove what we have to prove. We have to prove that EF is parallel to BC. So how will you prove? So you have to prove using the BPT theorem, as the question given that you have to use using the BPT theorem, or it is actually a converse of BPT. So how will you prove? So as you know that AE is equal to EB, because the E is the midpoint of AB. So AE is equal to EB. So you could write here the AE is equal to EB. Why? Because the E is midpoint of AB. So you could write this one. Now this one. Now another thing the AF is equal to FC, because F is the midpoint of AC. So as you get, this one is the first equation and this one is the second equation. Now simplify this equation, you will get the EE is equal to ED multiplies the 1, because whenever you multiply then nothing is going to change. So this can be written as the AE is equal to ED by 1. This can be written like this, and this equation can be written like this: AF by FC is equal to 1. So this is the first equation, this is the second equation. Now when you will see a closer observation, the RHS side in both of the equation is equal, then LHS will also remains equal. So from 1 and 2 you will say that AE is equal to ED, which is equal to AF is equal to FC, because the RHS is equal, then LHS is equal. So if AE is equal to EB, so now you are getting that AE is equal to, we have this one as AB, AB here, and we have this one is AB, and here is also EB and AB. I had just written the D. So as we have the AE is equal to EB, which is equal to AF by FC. So now you got to this conclusion. So using the converse of BPT, you could say that it is the EF is parallel to BC. So if BE is parallel to BC, then AE by EB is equal to AF by FC, and this is what we get. So you will say that using the converse of BPT, the AE or EB like this when you get, then it is a parallel to the EF and BC. So now you could say using the converse of BPT, because you have get to this conclusion, and it is only possible when these lines are parallel. So I think you get to understood how we have to prove this one, and now solving the another question based on this concept. So ABCD is a trapezium in which, let's suppose a trapezium, make a trapezium here. This one is a trapezium named as the A, B, C and D. Now we have the ABCD is a trapezium in which AB is parallel to DC. This one AB is parallel to DC as we have given, and its diagonal intersect each other. What is the diagonal of this trapezium? The diagonal of this trapezium is this one and this one is the diagonal. This one and this one is the diagonal. Let's suppose name the intersection of the diagonal as the point O. So each intersect each other at the point O. So diagonal intersect each other at the point O. Here intersects both of the diagonal. Okay. So that we have to show that AO OB is equal to CO CD. So how will you get to this conclusion that AO BO? We have to prove. To prove what we have to prove? We have to prove that AO, that means this one, by BO is equal to CO by DO. So how will you get to this answer? For this you have to think how can you get. Just you have to remember, you have already learned one concept named as the BPT. So you have to use somewhere the BPT. For this we have to make a triangle in which two lines should be parallel. But let's suppose we have this line is parallel to this line, but it is not coming in any type of the triangle. So how will you use the concept of BPT? So that you will not able to use. Now you have to think, if you are not able to use, then you have to make a construction in the question so that you could use. So now draw a line named as the DO which is parallel to the AB. When you draw a line here, right here, the construction, draw DO parallel to AB. So if the DO is parallel to AB, then DO will also parallel to BC, because the AB is already parallel to the DC. So you could also say that the DO is parallel to the DC, because the AB is already parallel to DC. This is why you could say. Now if you want to understand, then I am going to tell you. As we have through the construction, we have written DO is parallel to the AB. Now we know that the AB is parallel to the DC given in the question. Now the LHS, here the LHS, so at the place of AB you could write the DC. So now the DO is parallel to the DC, like this you could write, and I think this is the basic thing which you get to understood. So now we get that the DO which we get through the construction which is parallel to AB and the DC. Now we have to get this one. So how will you use this concept? Now when you draw, then you get a triangle where the two lines are parallel. That means you could use the concept of BPT. So now what we have here? So here we have that the triangle we get that ADB. The triangle we have ADB, in which if you able to see over a closer observation, you will able to see that let's suppose this point as the D dash, because already we have here the D. So right here the D dash. So if you able to see that in triangle ADB, we have the line D dash O which is parallel to the AB. So you could write that D by D dash, A by D dash, which is so through this you could write that the DO by OB, which is equal to DO by AB, which is equal to DD dash by AD dash. So now you could write this one using the first equation, name as this one as the first equation. Now as you able to see that we have get the another triangle in this figure like this. Let's see this triangle. As you able to see this triangle name as the ADC. So in this triangle you are able to see that this line is parallel to this line. So you could write here that AD dash by D dash D is equivalent to AO by OC in this triangle. Now as you get this one as the second equation, now AD by D dash, here we have and here we have also AD by D dash, but it is in opposite, so make it reciprocal both the side in this equation. So you will get the D dash by D or A by D dash and reciprocate this side OC by AO. Now this one is also a second equation, but it is in the simplified form. Now D by D dash by A D dash, and here we have also. So this is equivalent to this one and this is equivalent to this one. So through this both you could write here that DO is equal to OB, which is equal to OC by AO. And now what you have to prove? AO we have to make cross multiply. So here you will get the AO and here we have the OC and the OC here, and we have then we and here we get now this is what we have to prove, and as we get to the answer, and I think you understand how we get to this answer, and this is very interesting and easy question. Now solving the another question, which is our last question of this exercise 6.2 of the chapter name triangle, and then after I will start the 6.3. So the diagonal of the quadrilateral ABCD intersects each other at a point O such that, so as we get now diagonal of a quadrilateral. So let's suppose this is a quadrilateral in which name as the A, B, C, D, and the diagonal we have the DB and the OC. So as we this one name as the O, and now we have given that AO by BO or CO by DO is given. It is given so that ABCD is a trapezium. So now we have already that AO by BO and CO by DO. And in the previous question, in this question, as we get that ABCD is a trapezium, in which we are able to prove that this one, when ABCD is a trapezium, then this is possible, and when this is possible, then ABCD is a trapezium. This is like a converse of 10 number question is a converse of 9 number question. So using this same concept, you could say that it is the trapezium, and this is what we have to prove. And if you also wanting if you are not able to understand, then I am going to teach you. So using this is the same thing like the question number 9. So let's suppose we have this one name as the D dash, and again we have D dash which is the parallel to let's suppose this is the quadrilateral we have in which D dash we drew, which is parallel to the AB, and this is parallel to EC. And when you use the same concept, then you will get to know that the AO is equal to BO or CO is equal to DO. So when it is possible, when it is going to come, only when the AB is parallel to DC, and it is going to come only when the AB is parallel to DC. And if the AB is parallel to DC and ABCD is a quadrilateral, and in which the one pair of side is the parallel, then it is a trapezium, because the trapezium defined as a quadrilateral in which one pair of opposite side is parallel, and this is what the condition we have. So we could say that it is a trapezium. And thank you for today.